Hey everyone, in this example we're going to show you how to do a simulation of overbooking. This is a very simple model where we say we have 19 tickets. My ticket price per seat is 150 bucks. The probability of a no-show is 10%. If you get bumped, you get paid $155 and we will accept 22 reservations. This is very typical to what you'd see with an airline. So if you ever want to know how they bump people, this is a very simplified model for it. So the first thing we are concerned about is the number of passengers showing up. For this, we are going to go in and we are going to use a binomial distribution. Okay, so you'll see we have our ING binomial, which takes a number of trials and a probability of success. So our number of trials, right, is our number of reservations accepted. And our probability of success is 1 minus the probability of a no-show. So that means 90% of the time people actually do show up. So if I hit enter, you'll see, and I'll hit F9 a few times here, things jump around, 18, 19, 20, 22, all that kind of thing. Okay? So that's pretty good. I can get my passengers showing up. We can stay in good shape. The next thing that we want to calculate is my ticket revenues. Okay? My ticket revenues, well, that's my reservations accepted times my price per seat. That's a very straightforward number. Okay? Ticket revenues should be my reservations accepted multiplied by my price per seat. So I have 19, 22. See, we can bump these around to mess with things. Maybe you want to change this to 19. And this is normally what you'd be doing in a model, right? You plug in some numbers, you'd recalculate it, see what happens. And we'll be doing very similar things here in just a moment. So we go ahead, we've calculated those values. Now we're going to look at the opportunity cost of empty seats. What is that opportunity cost of empty seat? Well, it is my ticket price per seat, 150, times the maximum of tickets, 19, minus the number of passengers showing up, or 0. Okay, so I have the price per sheet times this. Okay, so you'll see here my opportunity cost, well, it's $150. Maybe I want to up this. Ticket revenues, we can mess with these numbers, take a look at them a little different way. But fundamentally, what my opportunity cost of empty seats is, right, it is B4, right, it's the $150 times the max of the people not showing up. Okay, pretty straightforward. Okay. I then have my bump cost. My bump cost is equal to my cost of bumping times the max of my number of passengers showing up minus my number of tickets and 0. So what we have here is we are multiplying the cost of bumping someone out of their seat times the maximum of the number of passengers showing up minus the tickets I've sold, right? And then we have the 0 here. So we'll see how this works. Okay, so I have 19 tickets, 19 passengers show up, 0 bump costs. That's great. Let's hit F9. 19 tickets, 18 passengers show up. Oh, sorry, I hit that one more time. We're going to let that calculate through. 19 tickets, 21 passengers show up. Well, I now owe each of those passengers $155. That gives me $310, but I don't have any empty seats, so I don't miss out on any opportunities there. Okay? In the end, I end up with what I'm going to call here my marginal profit. Okay, my marginal profit is my revenue minus my costs. So my opportunity cost and my bump cost. Okay, so in this case, we're looking at $2,990 in marginal profit. Okay, so this is all good. This is sort of our objective. Where does this go? But if I press F9 a couple times here, you'll see 3145. If I press it again, it's going to jump around a couple more times. And you'll see I'm actually starting to have a problem here that's similar to something you're going to see. This is jumping around, but every time I hit F9, it's running all the simulations from my other worksheets in here as well. So it's starting to slow down just a little bit. Okay, so you'll see if the same numbers show up, all these kind of things. Well, really what we want to do is we want to do this analysis of what's the best number of reservations to accept, right? This 19 right here. So what we're going to do is we are going to build a table. We are going to run 10 trials. And for each trial, I want to look at a different number of reservations accepted. So I'm going to look at 19, 20, 21, 22, 23, 24, 25. Okay? The way I make a two-way data table is I put a reference to the value that I want to look at right here. And I want to look at this $3,300. And then I select the whole table. I go into my data ribbon. I click what if analysis, and I pick a data table. Okay? My row input cell is my number of reservations accepted. So what does that do? By telling it that's the row input cell, it goes across this top row, and for every trial down the left, down here, it takes that 19, plugs it in there, and then reruns the simulation. And it does that 10 times. Does the same thing with 20. Put 20 in there, run it 10 times. To get it to do the 10 iterations, I need to pick an empty cell for my column input cell so that we're in good shape. And if I hit OK, I get a bunch of values in there. I'm going to make them look like dollars and cents so they look a little cleaner to you. And you'll see some of them are all misformatted. My formatting is all over the board here. We're going to make them all the same font and size. Okay? And for each one, I do want to look at an average. Averages are good to look at. I also want to look at that standard deviation. And I'm going to take both those formulas, take them all the way across. We'll do our average, we'll do our standard deviation. And then what we'll do is we will hit F9, and we will see what happens. Now this will take a second to run through all these trials. You see it has to run this a bunch of times. So it's going to take a minute, but in a second here, everything will update. You'll see it's flopping around quite a bit. Now I have a bunch of values here. You'll see I can look through these 2490, 28, 3000, 3114, 3155. It looks like my optimal value is going to be somewhere in here, even though I have the highest average, but I also have a little wider standard deviation. So it really is going to matter what I am maximizing for in this, what I am trying to do. But this simulation model is going to give me a good idea of how I should run my business. Right? The other thing you can do, you can actually build a confidence interval for all of these, right? So you could say my upper CI and my lower CI. Now, if you remember, this is my average, right? My upper is my average plus 1.96 times my standard deviation divided by the square root of the number of samples. Do that. If we look all the way across, we can see here what that is. You'll notice if I actually open up the formula, it actually does that recalculating for me as well. So this is one way to get through that really quickly. And then I can bring this down here. I need to move this up, change this to a minus. And then we can look through all these and say, oh, this is where I sit. This is the best place to be. So you can see 95% of the time, I'm still probably going to end up being somewhere around here or maybe here. But we're probably looking at taking 22, 23 reservations and working through that. So this is how you do a basic overbooking model. This is how you build a two-way data table where I'm just replacing the row. Okay? Now I could do this a different way, right? So I could say I have a different number of passengers showing up. I could do some more unique things and do some deeper analysis. But for now, this is where we're going to leave it. So you should be good to go.